Hello friends, welcome to Suresh Agarwal's Mathematics Shortcuts. Yet another important video in the most important chapter of surface areas and volumes. Especially important for class 10 students because these questions are all previous year questions which have been asked in board exams. And in competitions, surface area and volume chapter you can't escape. So you need to watch the entire video and learn the skill how to find the volume of combination of solids. So more than one solid will be there in a particular figure and we have to ensure we are able to find the volume of such solids comfortably and accurately. So let's take the first question. So in this question there is a solid iron pole and that iron pole consists of a cylinder of height 220 centimeter. So let's draw a cylinder. This is a cylinder. The height of this cylinder is given in the question as 220. Let's assume that this is capital H, okay? So capital H is given as 220 centimeters and base diameter of 24. So this diameter is 24. So the radius capital R is 24 upon 2, that is 12 centimeters. So the dimensions of this cylinder are given, which is surmounted by another cylinder of height 60 centimeters and radius 8 centimeters. So radius here is 12. So we have another cylinder surmounting this particular cylinder like somewhat like this, right? So I have drawn a schematic figure here. Now the radius of this part, small r, is given in the question as 8 centimeters and the height of this part, small h, is given in the question as 60 centimeters. So all the dimensions are given in the question. We need to find the mass. Now how do we find the mass? The formula for mass is volume into density. Volume into density. Now if you see the question carefully, the density is given here. See, this is cubic centimeter. 1 cubic centimeter of iron approximately is 8 grams of mass. So that 1 cubic centimeter, how much weight does it have? That is actually the density of the material of the pole, right? So this density is given in the question here as 8. Okay, so 8. Now if we multiply the volume by 8, we will get the total mass in grams of the pole. So what do we have to do here? We have to find the volume of this particular pole. So the volume is the volume of cylinder at the base and the volume of cylinder on the top. So I am going to use the conventions pi r square h plus pi small r square h. That is why we assumed with different alphabets here, capital R, small r, capital H, small h. Now pi is a common factor and we can put the remaining values here. Capital R is 12, so 12 square 144, capital H is 220 and then small r is 8, so 8 square is 64 and small h is 60. So I put all the values here and now I think 22 by 7 times. Now we can take out the common factors from here and then solve it, or you can do it directly also. In any way you feel comfortable. So I can take a 16 out and then between this and this I can see 20 as a common factor. So these are the ways you simplify your calculations, okay? So 16 9 times and then 20 11 times plus 16 4 times and 23 times. Still you have common factors. See, 3 and 9, it has a common factor 3 also. So solve like that and let me know what is the answer for this question. So I am leaving this small calculation for you. You have to post your comments and tell me this DIY question, do it yourself question, and I'll check the comments whether you got it right or not. Okay, so this is the volume. So you got to put the volume here and find the mass of the pole. And if the mass exceeds 1000 grams, convert it into kilograms. That is pretty elementary, right? Okay, let's see the next question. Find the volume of a solid in the form of a right circular cylinder with hemispherical ends. So cylinder, I am making it as a horizontal cylinder like this. and it has hemispherical ends like this and like this. Hemispherical ends. Total height is 2.7. So from here to here total height is 2.7 meters. And the diameter of each hemispherical end is 0.7. So diameter, this part, is 0.7 meters. So let's first calculate the dimensions. Small r, the radius. Since the diameter is 0.7, it is 0.7 upon 2 or 7 by 20 meters. I will leave it like this only. And what about the height of the cylindrical part, this part, h? We can calculate h by taking the total height, which is 2.7, and subtracting what? 1 radius and 2 radius from this. See, the remaining part actually is the height of the cylinder. So 2r, and that will give us 2.7 minus the diameter is already given as 0.7, so r plus r is 2r, 2r is diameter, so 0.7, so h is 2 meters. Now I will use h as 2 meters and r as 7 by 20 meters and find the volume of this solid. So volume of the solid, very easy, add the volumes of the three figures. So pi r square h, that is the volume of the cylinder, plus double of the volume of the hemisphere, which is 2 by 3 pi r cube, right? So I can take the common factors now. Pi r square is a common factor which gives me h here, and if I take pi r square, 4 by 3 r is left inside the bracket as the second term. Now let's put the values here. This is pi r square, pi is 22 by 7, r is 7 by 20, so 7 by 20 times 7 by 20, right? Pi r square, h is 2 plus 4 by 3 times 7 by 20, right? So 7 cancels out, you have a 10 and 11 here, so this is 77 by 200 times 2 plus 4 5s are, so 7 by 15, which gives me 77 by 200 times 37 by 15, and that will give us our final answer for the question. So I am leaving one small calculation for you because I don't think this is like consuming too much of time. We have zeros here in the denominator. So you can let me know in the comments what is the answer for this question in cubic meters, because the dimensions are in meters, so the volume will be in cubic meters. So that's how you solve this question of this particular solid. Likewise, we have a question here where there is a juice seller who was serving his customers using glasses, and the inner diameter of the cylindrical glass is 5 centimeters. So the glass is like this, So we have drawn a glass. The inner diameter, so this diameter is given in the question as 5 centimeters. Now, but what is he doing? The bottom of the glass has a hemispherical raised portion which reduced the capacity of the glass. So he is acting smart. He has a hemisphere like this inside. So the juice only comes in up to this level and not up to this level. Okay. Now the height of the glass is 10 centimeters. So this is 10 centimeters, and we need to find the capacity, right? Find the apparent capacity. That means the glass looks like it is straight, but it is not actually. This part doesn't contain any juice. So there is an apparent capacity. That means the customers will see the glass as full thing. So that is the wrong capacity. And the actual capacity also we have to find, both the things, right? So h obviously is 10 centimeters and r is diameter is 5 centimeters, so 5 by 2 centimeters. Now given these dimensions, you have to find the apparent capacity. Now if I find the apparent capacity, the apparent or the unreal capacity will be just the capacity of the cylinder, that is pi r square h. So very easy, I just have to put h and r here and get the apparent capacity. So 22 by 7 times r is 5 by 2, so 5 by 2 2 times, and then h is n. So I don't think there is a problem here. We can solve it and get the answer in centimeter cubes. But the real capacity, that is little challenging. How do you find the real capacity? For real capacity, from the apparent capacity, we need to subtract the capacity of this hemispherical part, right? So real capacity we have already found out, right? So that capacity minus the capacity of the elevated part, that is hemispherical part, 2 by 3 pi r cube, will give you the real capacity of the glass. So you have to find 2 by 3 pi r cube here. This is already found here. So see, this is all getting cancelled. 2 is like this 11, and then this 2 is 5. So you get 5 into 5 into 5 into 11 by 7. So it simplifies your calculation more. The radius is 5 by 2, so we can find 2 by 3 pi r cube also, and then subtract it from this value which we obtain here. You will get the real capacity in centimeter cube. So mind you, real capacity is less than the apparent capacity, right? So this is how you solve this question. And then we have another question where there is a spherical glass vessel which has a cylindrical neck. So how do you draw this figure? So there is a cylindrical neck. I will draw the neck first. See, like this. And this spherical glass vessel is somewhat like this. See, like this. This is the shape. Now, what are the dimensions given? Cylindrical neck is 8 centimeter long. So this height is 8 centimeters. So h is 8 centimeters. 2 centimeter in diameter. So this radius, small r, is 1 centimeter because the diameter is 2. So radius is 1. The diameter of the spherical part is 8.5. So this radius, capital R, is 8.5 upon 2. That is 85 upon 20, which is 17 upon 4. Right? I cancel the common factor out. So this is centimeters. So now I know everything in this figure. See, there is no other dimension which is not known. So we have to find the amount of water it holds. That means the volume of the vessel. So volume of vessel is simply the sum of the volumes of the two figures here. Pi r square h for the cylinder and 2 by 3, not 2 by 3, this is sphere, right? So 4 by 3 pi r cube for the hemisphere. Now we need to take care about one thing. The radius of the two figures are different. So in the case of the sphere, we have assumed capital R. So you should ensure that you are putting the correct alphabets. And then take out the common factor. Only pi is a common factor here. So that gives you r square h plus 4 by 3 r cube in the bracket. Now I can put everything here and get the volume. So pi is 22 by 7 times r. Small r is 1, so I don't need to write 1. 1 square is 1, which gets multiplied by h and gives you h only, right? So h is 8, so I'll just put 8 plus 4 by 3 times r cube. Now this is where the problem is, 17 by 4 cube. So 17 by 4, 17 by 4 and 17 by 4. So one of the 4's will get cancelled and the other things you have to do. So 22 by 7 times 8 plus, we have a 17 times 17, 289 times 17 upon, this is 4 times 4, 16, 3s are 48. So we have to do this calculation now and ensure that we get 345 centimeter cube nearly as the answer. So this answer is already given here, 345 centimeter cube. Just need to verify whether the answer is correct or not. That's what he is asking us to do here. He has asked us to use pi as 3.14. So if that works, you can remove 22 by 7 and put 3.14 so that you get more closer to the correct answer, right? So friends, very important video, finding the volume of combination of solids. So do share it with your friends. Don't forget to subscribe the channel and click the bell shaped icon for getting the notifications. Look for the next part of this series of videos on surface areas and volumes. Thanks for watching this and all the best for the questions given in the practice worksheet.